Okay, what we're doing today, guys, is, there we go. We are going to simplify our logarithmic expressions. So we've already been just writing them and going back and forth from exponential to log, and so today we're going to be simplifying and reducing and making it smaller. So remember, our base of the exponent is the base of the log right here. Our exponent is the actual logarithm, what the log is equal to, and then our number is what we are taking the log of. So we should be able to go back and forth pretty easily now. And remember, if we have something like 5 to the third power equals 125, we could rewrite that as log base 5 of 125 equals 3. And if we're going from log to exponent, remember, we start at the base, we go around, raise it to the exponent, and it's equal to where we end up. Okay. So let's refresh ourselves a little bit first with examples 1 and 2. We want to rewrite the equation from logarithmic to exponential form. So this is what our homework was last time. So remember, we start at base 5. So this is 5 to the 1/2 equals square root 5. And is that a true statement? It is a true statement. Okay. So will you guys do number 2 really quick? So what did you guys get for number 2? Excellent. 3 to the negative 2 equals 1 over 9. True statement? Yep. Okay. So let's go the other way now. Let's for 3, 4, and 5, we want to write from exponential into logarithmic form. Now I think this is a little bit trickier, but let's see. We have a base of 2, so this is log base 2 of 32 equals 5. Okay, and just to double check, let's go around to make sure that we did it correctly. 2 to the 5th equals 32, so we got it correct. Okay, so that would make number 4 log base 10.
Wait, can you just not write anything?
Yeah, we can also just not write anything. I'm going to do that too. Okay, so log base 10 of 0.001 equals negative 3. Or, you guys remembered, when we have a base 10, we don't have to write anything. So that would be log of 0.001 equals negative 3. Okay. What you will very rarely see it written log base 10. It will just be log. Okay, so just start getting used to that. I'm sorry? Correct. Because our numbering system is in base 10, you know, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we start over. Everything's in groups of 10. For logs, when we have a base of 10, we just don't have to write it. Yeah, but it's the same thing. Okay, so what would number 5 be? Log base 7 of 49 equals 2. Easy so far, right? So far. Okay, so for the next page, we're actually going to be simplifying these things. So we're going to be given a log, but we don't know what it's equal to yet. So we need to actually figure out what it's equal to. So there's some steps that we have to follow. Oh, I don't know why that's... Okay, so number 1, we first set the equation equal to x. So if it just gives you log base 2 of 10, not equal to anything, we set it equal to x. We write the equation in exponential form, so we go around and write it as an exponent, which is going to give us kind of what we were looking at in the last unit. We need to rewrite each side so it has the same base. Then we can drop the bases and solve for x. So everything that we did in 8A is now coming back in 8B. All right, so let's look at the first 5 examples. I'll keep them. Okay, so log base 7 of 49. We want to know what that's equal to. So we set the whole thing equal to x. And then we want to rewrite this in exponential form. So we go around, which gives us 7 to the x equals 49. So what's my base going to be here? 7 to the x equals 7 to the second power. Now I have the same base, so I can drop those bases. So I get x equals 2. Not too bad, right? So number 2, same thing. We set the whole thing equal to x. So we have log base 3 of 1 over 27 equals x. We go around. So 3 to the x equals 1 over 27. Okay. So what's my base going to be here? 3, right? 27 is 3 to the third, but we need to bring it up top, so that's going to be 3x equals, or 3, oh my gosh, to the x equals 3 to the negative third. Up those bases, so we get x equals negative 3.
Why is it negative?
Because it's a fraction, and we want to bring it up, which means we have to change, if we're taking the reciprocal, we have to change the exponent to negative. Okay, because right now it's a fraction, so the bases are not the same yet. Make sense? Okay. So number 3. Set the whole thing equal to x. So that gives me log base 4 of 16 root 4 equals x. So that is 4 to the x equals 16 root 4. Now this is very similar to the ones we did on the test, right? That was our most missed question. 16 is 4 to the what? 4 to the second. So this is 4 to the x equals 4 to the second times 4 to the square root is an exponent of 1/2. Okay? So we need to combine these first before we can do anything else. What do I do with exponents when I'm multiplying the bases? Well, we add them, right? So we need to get a common denominator here. So we have, I'm going to rewrite this, 4 to the x equals 4 to the, we want to add these guys, 2 plus 1/2, right? And we need to get a common denominator of 2. So we multiply top and bottom by 2 here. So that is 4 to the x equals 4 to the 5 over 2. Now I can drop the bases, right? Yeah.
You got money from Smart?
Yeah. There you go. Thank you. You guys okay with that one? Okay. Alright, so we have coming around 2 to the x equals cube root of 1/4. So let's first rewrite this so it's an exponent. If I'm taking a cube root, the exponent is what? 1 over 3. Because a root is a fraction exponent. So this is the same as 2 to the x equals 1/4 to the 1/3. Okay. So this is, I'm going to come back up here, 2 to the x equals, what's 1 to the 1/3? Cube root of 1 is 1, right? So is everybody okay with rewriting it like this? Because taking the cube root of 1 is still 1, right? It doesn't change the numerator at all. So we only have to worry about the denominator. Just because the numerator is 1, okay? Okay. Alright, so we need to get this 4 to be a base what? A base 2. We're not going to flip it just yet. Okay? We need it to be a base 2. So this is going to be 2 to the x equals 1 over 2 to the what? Second, but we're dividing by 3, so it's going to be 2 to the 2 over 3. Right? Because we're multiplying those. Okay, now to get the 2 up top, what do I need to do? Make it negative. So this is 2 to the x equals 2 to the negative 2 over 3. That exponent does not flip, just the base flips. The exponent only just becomes negative. Okay, so then x equals what? Negative 2/3. Okay, so last one, number 5. We have log base 1/2 of 16, so we set it equal to x. And then we go around and rewrite it as an exponent. So this is 1/2 to the x equals 16. So I'm going to be getting a base of what here?
2.
A base of 2. This 1/2 does not have base 2 yet, so what do I need to do? Make it a negative 1. So this is going to be 2 to the negative x, right? Equals 2 to the 16 is 2 to the 4th. Good. So I have same bases now, so I can drop the bases. So I have negative x equals positive 4. So x equals negative 4. So here's our reminder. If there is no base stated, then we assume that the base is 10. And this is actually a definition. It's called a common logarithm. Okay, so that's why we don't have to write it. Because if it has a base 10, it's called the common logarithm. So we don't have to write it. It's just assumed. Okay, so I've just put that in a box to remind you guys. So we're going to be working with that for the last 5 examples. But everything that we're going to be doing is exactly the same that we just did. So we set the whole thing equal to x. But since I don't have a base stated, I assume that it's 10. So this is going to be 10 to the x equals 1,000. So I need to get a common base. My common base is going to be 10. So this is 10 to the x equals 10 to the... How many zeros are there? 3. So 10 to the 3rd. So I can drop those bases and I get x equals 3. Okay, same thing for number 2. We set the whole thing equal to x. There is no base stated, so we assume it's a 10. So 10 to the x equals 0.001. Now this is scientific notation, right? We want a base of 10, so this is 10 to the x equals 10 to the negative 3, because I have to move the decimal negative 1, 2, 3 spaces. So I can drop those common base, and I get x equals negative 3. So number 3. Same thing. Set it equal to x. Common base, so we assume base 10. 10 to the x equals 2. No, 10 to the x equals 10 to the 2nd. Sorry. So we already have common bases, right? So we can just drop those and x equals 2. Okay, number 4. Set the whole thing equal to x. There is no base listed, so we assume 10. 10 to the x is equal to 1 over 100. Now 100 is 10 to the what? 10 to the second. So it's going to be 10 to the x equals 10 to the negative 2. Drop those bases, so x equals negative 2. Yep. And last one. Set the whole thing equal to x. There is no base, so we assume 10 to the x is equal to square root 10. But square root 10 is exponent of 1/2. So this is 10 to the x is equal to 10 to the 1/2. So drop the bases and x equals 1/2.